Assalamualaikum and good day again everyone. We are continuing with our final part 3 for our chapter 4. We're doing for the cumulative distribution function. So I hope you still understand the meaning of cumulative. What does it mean by cumulative? Meaning that you accumulate or you sum up, alright? So again, for this chapter we only focus on discrete random variables. Continuous random variables, we only do it in next chapter, chapter 5. Sorry, previously I mentioned in chapter 6. No, it should be in chapter 5, right? So chapter 5 we will go for the continuous random variables. Now we look back at our cumulative distribution function. What does it mean? So in this case, it's actually a function giving the probability that a random variable x is less than or equal to x for every value x. Alright, so for every value x you have the probability. Okay, cumulative distribution function is found by summing up. Okay, so again you have the symbol here, means you sum up all the probabilities. So your pxx here is also known as your probability distribution function, which we did previously, and sometimes you can shorten it using the PDF only. Alright, so probability distribution function, this is your cumulative distribution function, your CDF. Okay, let's take a look at example 7. Now you're given here the probability distribution. Okay, you have the x 0 until 3, and then you have probability when x is 0, x is 1, 2 and 3, and you want to find the cumulative distribution. So what you do is basically you take back your x, alright, and also you take back the probability for each of the x, and finally for the cumulative distribution function, this is where you have to sum up all the probabilities. So when your x is 0, your cumulative probability is still 0. Your cumulative probability is still 1 over 30 because it takes back the probability when x is 0. But when you want to do for your f1, okay, when x is 1, you want to find for the cumulative distribution when x is 1, you have to take back your px when it's 0 and also your probability when x is 1. So basically you add these two parts here. Alright, or you can say you take back your cumulative probability when x is 0, and then you add with probability when x is 1. Okay, so basically you can see, okay, you go up there. Alright, okay, you can also take this plus, alright, 1 over 30 plus 3 over 30, then you get your cumulative probability when x is 1. And then the same goes, you want to find for cumulative, you want to do for your cumulative distribution function when your x is 2, you take here and then you add these two values, you get 25 over 30. So you're taking 10 over 30 plus half. Okay, half is 15 over 30, so 10 plus 15, 25, so 25 over 30. And finally, for you to get when your x is 1, you take this and then you take this value and then you add again. Alright, so in this case here, it's your 25 over 30 plus 1 over 6. Okay, 25 over 30 plus 1 over 6. So you get exactly 1. So take note, the final value here must always be equal to 1 because you add all your properties value here. Okay, so all the summation here, and then the final value will be 1. So this is your cumulative distribution function. This table here is your cumulative distribution function.